So a car wheel 30 centimeter in radius is turning at a rate of 8.0 revolution per second when the car begins to slow uniformly to rest in a time of 14 seconds. Find the number of revolutions made by the wheel and the distance the car goes in the 14 seconds. So it's a kind of circular motion because it's about car wheel. We are told that the radius of the wheel is 30 centimeter. The radius of the wheel is 30 centimeter and it's turning at a rate of 8 rev per second, and this is the angular velocity, 8.0 rev per second. Okay, when the car begins to slow down, slow uniformly to rest. So this must be omega 1, and omega 2 must be 0 because it is slowing uniformly to rest, okay, in a time of 14 seconds. 14 seconds. You have to find the number of revolutions made by the wheel, and then the distance the car travels in 14 seconds. So, looking at the solution provided by some of you, I saw somebody using angular velocity is equal to 2 pi over the period. And because period is equal to total time over the number of revolutions, this was substituted and I saw 2 pi n times t. When the person finds n, or when you find n, you have the number of revolutions as required by the question. Yes, this is a good one to use. But then, you see, the body or the wheel is not traveling at a constant angular velocity or uniform angular velocity. Don't forget that you were told that the car wheel, okay, slowly, it begins to slow uniformly to rest. So omega is reducing to 0. So if omega is reducing to 0, then you must use the concept of average angular velocity, which is theta, or you must, instead of theta, the concept of average velocity. So omega average within the time interval will be equal to omega 1 plus omega 2 divided by 2. Omega 2 is 0. So the average velocity here will be omega 1 over 2, which in this case will be 8 rev per second over 2, which is 4. Okay, so if you are going this way, then the equation must be omega average will be equal to 2 pi n over t. And this is omega. Please mute yourself if you haven't done so for us, okay? So we have 4 rev per second is equal to 2 pi over 14 n. Okay, quickly, because the time and all that is in seconds, quickly change this to radian, and you have 4 revolution per second, or 4 rev will be equal to 4 times 2 pi radian per second will be equal to 2 pi over 14 n. Okay, and we'll end up having n. Don't forget, when you make n the subject, when we make n the subject, we'll have 2 pi will cancel out. This and this will cancel out, and n will be equal to 4 times 14. And 4 times 14 is equal to 56. So the number of revolutions here will be equal to 56. Okay, so if you are going by this, that is what you must do. If you don't want to use this and you want to use one of the equations of motion, then use omega 2 squared is equal to omega 1 squared plus 2 times alpha theta. Okay, in this case, you must determine alpha, and alpha is equal to, from equation 1, omega 2 minus omega 1 over t. So we'll have omega 2 is 0, and omega 1 is 8 over 14. And we'll have this in minus, what is 8 over 14? 4 on 7. What is 4 on 7? Give me this in decimal. 4 on 7.
0.5714.
5714. This is rev
This one. Yeah,
per second squared. So having obtained this, you substitute this into the equation. This is 0 is equal to omega 1 is 8 squared minus, plus 2 times whatever we had negative 0.5714 times theta. So multiply and then make theta the subject. So we'll have 2 times this. I'm letting this cross the equal sign. So 2 times 0.5714 theta is equal to 64. Please, let's divide through by what is there to get theta. What will be the value of theta? Do that for me. Multiply 2 by 0.5714 and divide 64 by that. I'm waiting for you, so. Are we through?
Please, 56.002.
So 56 rev. So if you are going this way, both situations or cases must give you the same results. And then the next question, find the distance. The distance here has to do with the linear displacement, r times theta. The radius is 30 centimeters. So we have 0.3. Okay. Then if you change this to radian, 56 times 6.286 radian, you must get something close, I think 105 or so, 105 meter. Please point it and then let's see. Please don't forget that 2 pi is the same as 6.286. So 0.3. Are you confirming that, please?
Yes, please. 105.6048.
Exactly. So approximately 105. So this is the way to go. Okay. This is the way to go. Then the second question is actually straightforward. A wheel, can I turn to the next page? Yes.
Yes, sir.
Yes. I'll not wait for you to even respond. But because I'll share the video, with a car wheel revolving at 6.0 rev has an angular acceleration of 4 radians per second. So straight away, because the angular acceleration is in radians per second, which is 4.00 rad or radian per second squared, and I'm giving the initial angular velocity as 6.00 rev. Quickly, I must convert this to radian. So this is 6 times 6.286 rad. Usually, when you substitute 2 bar, you have to calculate, you want number or express angular velocity in multiples of in decimal. So instead of using 2 bar, use the 6.286 direct. Okay, so 6 times 6.286, I have 37.716 radian per second as my initial angular velocity. Okay, and I'm doing this because the angular acceleration is in SI unit, radian per second squared. Okay, so find the number of turns. Please, when you join, Nanayao, mute yourself. Nanayao, mute yourself. Find the number of turns the wheel must make to reach 26 rev per second. So omega 2 is given as 26 rev per second. Okay, so I'm quickly converting this to radian per second. So 26 times 2 pi or 6.286. And what is, give me that product. 26 times 6. Go ahead.
163.36.
163.36. Oh, okay. I have. Oh, okay. 163.436. 436. Okay. Radian per second. Meaning, and I'm to determine the number of turns. So I can even use theta is equal to omega 1 plus omega 2. Oh, I'm to determine the time as well. Okay. I'm to determine, we don't have the time. So this will not help us straight away. So let's use, when we use equation, let me throw it to you. Which of the equations do we use? Will it be 1, 2, 3? Will it be equation 1, equation 2, or 3? Hello, based on what we have, which appropriate equation do we use? You are not talking.
That is equation 2.
Equation 2, I think 3 rather. Because if you use
equation 3.
Okay, so omega 2 squared is equal to omega 1 squared plus 2 alpha theta. Okay, so 2 alpha theta. Blagoji, mute yourself. Mute yourself for us. Okay, and equation 1, omega 2, we had 163.436. That's squared minus 37.716 squared. Then all divided by 2 times alpha is 4. Okay, and so we must be smiling. So just quickly compute and then give me the final answer. You can use difference of 2 squared to also do this. 0.436 plus 37.716 times 163.436 minus 37.716 all divided by 8. So just give me the final answer. What is the final answer? Anybody, if you have finished, quickly share with us.
Please, I had 3161.104.
Again,
161.
61.104. Okay, this is radian. Let somebody confirm. Then, if our answer is right, can you quickly change this to revolutions? Change 3,161 radian to revolutions. The answer is in red. So I just want to cross-check if you are right. I'm waiting. Oh, change this to red. Again. Oh, we are changing this to revolution. Don't forget, 1 rev is equal to
Okay, so I got 502.65.
Roughly 503 approximately. Yes. So the way out is that 2 per radian is equal to 1 revolution, and 2 per radian is 6.286. This is to 1 rev. So if you have 3,161 radian, class, will it be more or less? Would this be more or less in revolutions?
More.
It will be more. If more, let's divide. So you divide 3,161 by 6.286. Then you multiply your result by 1 rev. And your answer must be approximately 503. 503 rev. Are we okay? we are also to calculate for the time. Once we have the angular displacement or the number of revolutions, we can use theta is equal to omega 1 plus omega 2 times the average divided by 2, and then okay, make theta the subject. So here 3161 times 2 is equal to the sum of omega 1 and omega 2, which is omega 1 is 37.716 plus omega 2, which is also 163.436. So sum this up, then you divide through by the time. So please confirm the time for me. Just
Yeah,
work this.
I'll go for more. I'll go for more.
Just work it out for me. Class, I'm waiting for you, so let's hurry up. Mommy, yeah.
Yes, please.
I'm waiting for some of you to calculate for me. Nyansabuakwa, and then the rest of you. Jojo, are you there? Jojo is not here.
31.42.
Okay. So 31.42 seconds. That's the answer. Please, if you don't understand any parts, quickly let me know before we proceed. If you don't understand anything, let me know so we can continue. I'm waiting for you in about 2 minutes time. After 2 minutes, then Elizabeth.
Cynthia, please, for the same question, I was asking for the number of turns the wheel must make, but then we use distance, like
no, angular displacement is not distance. So angular displacement is the number of complete revolutions made. So an angular displacement of 360 or 2 pi radian means we have 1 complete revolution.
okay.
Is that okay? So angular displacement also means a certain number of angles made within a given time. Equally, you can also use omega is equal to 2 pi over Tn. So you determine n. But note that in this case, omega would be the average angular velocity because you have 2 different angular velocities.
Yes, please.
Who is laughing? Don't laugh. So your omega must be the average value. Are you okay?
Yes, please. Thank you.
Yeah, that's what I saw in some of the presentations or solutions that was sent to me. And it's a smart one, only that you missed out on how to determine omega. You see, this is also similar to, you see, in linear motion, velocity or speed can be determined by total distance over t.
Yes, please.
And then the same velocity can also be determined using one of the equations of motion. V is equal to u plus at. The question is, when do we use this and when do we use this? We use the first equation when the body's velocity is constant. When the body is moving with a non-changing speed or velocity, then you can use this to determine the distance traveled or the total time taken. When do we use this? We use this when the body accelerates. When the body is accelerating, it means it is moving with increasing speed or decreasing speed. So if the body's velocity or speed is not constant, but it changes with time, that is when we use equation 2. So we have a similar situation. If the body is moving with a constant angular velocity, then the omega value given is what we substitute here. If the body is not moving with uniform angular velocity, then you must pick one of the equations of motions, equations of circular motion to solve the problem. Lizzie, are you okay?
Yes, please. Thank you.
All right. We got to centripetal force yesterday. Centripetal force. So centripetal force, we realize, is the force. Nathaniel. Yes.
But sir, I used it, but I got the time to be where is it? I got the time to be 31 seconds, 0.42, the same answer as yours.
You say you use what?
I used this the motion, this
Okay.
equation,
So Nathaniel,
but I got this.
what I want you to do is that you send your solution to me after the class. I'll probe to see whether you were doing the right thing, but or it was just coincidental that you had the answer right. Okay.
Okay.
All right. I saw God love. Your hand was also up.
Yes, sir, please. I think I also send you my solution then.
All right. Okay. So centripetal force is a force which keeps a body in circular motion within the circular path. Now, when a body is in circular motion, let's see the body. There's the center of the circle O. So the body starts from this point A, then moves to this point B. So this is the new position of the body. The time taken to move from A to B, this is time T. The body describes a certain angle at the center. Let's call this angle delta theta. Delta because it's a small angle. We are assuming this to be small angle. The displacement from A to B, let's call this as delta S. Yeah, before we proceed, I ask you to do some reading that on centripetal force and the guideline or the areas where what causes or brings about centripetal force. centripetal force. Okay, and then the mathematical equation for centripetal force. What's the direction of centripetal force? Before I also come in. Yes, what causes centripetal force, class? Anybody, if you got something, share with us. What causes it? Yes, anybody who got some information can kindly share with us. Or you couldn't make time to read. Is that the case? So we proceed. Ladies and gentlemen, is that the case that you couldn't make enough time to read? Mamiya.
Sir, please, the question again.
I asked you to read on centripetal force, and the areas I gave you were the what is responsible or the causative agents of centripetal force, mathematical equation of centripetal force, and direction. Mamiya, what did you obtain?
Centripetal. The cause of a centripetal force depends on the situation.
Oh, I said this last time, but if you go deeper, there is something which causes it.
Okay.
The situation, yes, I know. That's why I said it's a pseudo force or false force. Anybody? Okay, let me take over. Or there's another hand. This is Kelvin. Yes, Kelvin.
Sir, please, I'm trying.
Go do so.
Sir, please, acceleration of the object.
So there will be acceleration. Okay.
And the
Mate.
mass.
Hey, wait there. Mate. Wait there, Mate. Nathaniel, what did you also obtain? What information did you come by, Nathaniel? Or if Nathaniel is not ready, Elsie. Elsie, let's see you. Or else you will see. Yes.
Sir.
Hello.
Please, I think magnitude, the magnitude of the object, and the direction where the centripetal force moves towards the center of the circle.
So you mean the centripetal force is directed towards the center of the circle?
Yes, and it depends on the velocity and radius of a circle.
Well noted. Elsie, if you have something to add, quickly do that.
Sir, please, friction and gravity.
That is a situational thing Mameya was trying to talk about. Okay, I understand you. Okay, so let me take over and then we go into it the better. Now, so the body has moved from a point A to a point B. The time taken to move from A to B is T. That linear displacement described within the along the track or the arc is delta S. Now this is about uniform circular motion. Uniform, right from the beginning, we are narrowing our scope on uniform circular motion. And when a body is in uniform circular motion, the body moves at a constant speed within the circle. So The body ideally is moving at a constant speed v within the circle. But when the body is in circular motion, at every time, the direction of the body is changing. So when the body is at A, this is the direction of the body. When the body is at B, this is the direction of the body. When the body is at, let's assume another position C, this is the direction of the body. So an object in circular motion has a changing direction with time. Now, because of this changing direction, even though the body is seen to be moving at a constant speed v, but because of the changing direction, each velocity at every point is different. So velocity at A is v1, velocity at B v2, velocity at C v3. Don't forget, velocity is a vector quantity, and it has to do with change in displacement with respect to time, or when constant speed with direction. So when the speed is constant, but the direction of the body continues to change, we have different velocities at different points. And this is due to the changing direction of the body. So the velocity at A is v1, or we can use VA. Velocity at B is v2 or VB. Please, are you clear with that? Are you clear with that, class?
Yes, sir.
Yes, please.
Yes.
Okay. Now, this velocity at different points A and B and C is always tangential to the circle. A tangent is a line which is always perpendicular to the radius of the circle. So the velocity v1 makes an angle of 90 degrees with the radius r. The velocity v2 makes an angle of 90 degrees with the radius this. The radius of the circle is constant. And when you use geometry, it will be seen that this angle, the angular displacement delta theta, will be equal to the angle between v1 and v2. Using geometry, we can prove that the angle between the two tangential velocities, v1 and v2, okay, is also delta theta. So when I redraw this, we have something like this. We have two velocities. This is v2. We have another velocity, v1. And this angle, we have this angle delta theta between them. Okay. So the two velocities have their direction. Now, if we use triangle law of vectors, then if this is going here and this is going here, v2 is in this direction, v1 is in this direction. When we join this point will be equal to the change in velocity between v1 and v2. Let's assume this is x. Okay, for triangle law of vectors, x must have a direction here, so that we can say that v1 plus x will be equal to v2. Elsie, please mute yourself for me. Elsie. So V1, I'm using triangle law of vectors, vector addition. V1 plus X is equal to V2. Okay, so that X is equal to V2 minus V1. X therefore is equal to the change in velocity between 1 and 2. So the change in velocity is equal to V2 minus V1. Class, are we okay? So this is the change in velocity, delta V, what we represented as X. Now, this angle delta theta is a small angle. That is the reason why we even have this triangle. This means small angle theta. If theta is small angle, then the angle over here plus the angle over here must approximately sum up to 180. You see, total angles in a triangle must add up to 180. But if this is very small, then we can also say that then this plus this must almost be equal to 180 because this is very small. In that case, we can say that this is approximately 90 degree and this is approximately 90 degree. Please, I'm using the word approximately because we are seeing delta theta to be very, very small. So assuming that is 0.1, then it means when we subtract 0.1 from 180, please subtract 0.1 from 180 for me. Subtract 0.1 from 180. You have 179, okay, 0.9. So yes, 179.9, meaning that these two, okay, are almost 180, and so this can be close to 90 degrees. This can also be close to 90 degrees. The reason is that this is very small. We are actually using the concept of approximation in doing this, which is not so much real. Okay. Now, if the change in velocity is almost 90, this angle between the change in velocity and V2 is almost 90. And this angle between the change in velocity and V1 is almost 90. Then it means that when I take V2 is almost perpendicular with delta V. I can also say that if I take V1 is also almost perpendicular with the change in velocity, delta V, because they are almost 90. Class, are you with me? Okay. So we are seeing delta theta to be very, very small. This is very, very small angle, which we are assuming is 0.1. I'm assuming. If this is very, very small, then the two angles summed up, the two angles here summed up would give us something close to 180. When I subtracted, we had 179.9. This is approximately equal to 180 degrees. Are we okay? Are we okay? Therefore, it means that the angle between V2, which is this, and the change in velocity is 90, almost 90, approximately 90. The angle between V1 and delta V is also approximately 90. If that is 90, then, you know, vectors are equal. So when I take V1, the angle between V1 and the delta V in this direction is almost 90. The angle between V2 and delta V in this direction is also almost 90 degrees, approximately 90. Okay. If this is the case, then it means that delta V is perpendicular to V2. Delta V is also perpendicular to V1. Okay. And each of these velocities, V1 and V2, is also perpendicular to the radius. Okay. We can therefore bring the direction of the change in velocity along the radius. We can bring the direction of the change in velocity along the radius, because vectors are equal no matter where they are if the direction, the magnitude and direction are the same. So if delta V is perpendicular to V2, delta V is perpendicular to V1, then we can bring the vector delta V along the radius, because the radius is perpendicular to V1 and V2 respectively. So we have seen the direction of the change in velocity. The change in velocity is acting along the radius. Okay. And what, class, let's build our points gradually. What causes the change in velocity? The change in velocity delta V, okay, is there because of the changing direction of the body. So the change in direction, the change in velocity delta V occurs due to the changing direction of the body in circular motion. Okay, so we have delta V due to the changing direction at A and then B and at C. Okay, now if you have a change in, okay, before I talk about that, the direction 2, so 1, 2, the direction of the change in velocity, delta V is towards the center of the circle. This is because we've seen the change in direction to be almost perpendicular with V1 and V2 respectively. So when we bring it along the radius, it will still be perpendicular to V2 and also will still be perpendicular to V1. That is why we see the change in velocity to have direction towards the center of the circle O. Now, class, whenever there is a change in velocity, what happens? Whenever there is change in velocity within a given time, don't forget the time taken for the body to move from A to B is delta is T, or is delta theta, delta T, sorry. Yes, Calvin, whenever there is change in velocity, what happens?
Sir, please, it creates acceleration.
It creates acceleration. So once we have a change in velocity, the body in circular motion would accelerate. This acceleration A is equal to the change in velocity V over the time. Don't forget, delta V we saw to be equal to V2 minus V1. So due to the changing direction of the body accelerates. Okay, let's figure out the direction of the acceleration. Let's figure out the direction of the acceleration. The change in velocity has a direction. What is the direction of the change in velocity? What's the direction of the change in velocity? Yes, class, we've talked about it. What's the direction of the change in velocity?
Towards the center.
Towards the center. Time has no direction. So because the change in direction, change in velocity has a direction, or it's a vector, the acceleration also takes the direction of the change in velocity, which is towards the center. So the body accelerates towards the center, towards the center of the circle, towards the center of the circle, or the acceleration of the body has a direction towards the center. Okay, so due to the changing direction, we have realized that there will be change in velocity at every point. And this change in velocity has a direction towards the center. And when there is a change in velocity, it means the body would accelerate, and the acceleration would also take the direction of the change in velocity. Now let's determine how to calculate for this acceleration. Let's determine how to calculate for this acceleration, which has a direction towards the center. So when we pick this one, we see the body moving at a constant speed v. So this is v, this is v. Please, we are taking this time. I'm not indicating 1 and 2 because we are only looking at the magnitude of the velocity, ignoring directions. So v here, uniform circular motion. The body is moving with constant speed v. So I'm looking at magnitude of the speed. And so we have change in velocity, the angle delta theta. This is giving us a magnitude we are calling as delta v. If we pick this inner circle, inner angle, we have this one too as this side is the radius of the circle. This side has the same value as the radius. The small arc creates change in this displacement s. The inner angle is also delta theta. Now, because we are considering small angle, when you consider small angle, the arc, whatever is along the arc seems to be perpendicular to one of them. So this side will look like being perpendicular to this, and this will also look like being perpendicular to this. So if you take the sine of this first one, sine delta theta, this will be equal to the opposite, which is delta V over the hypotenuse, which is V. If you do the same thing for this, you also have sine delta theta, which is equal to the opposite, which is delta S over the hypotenuse, which is R. So we have two equations, okay? Sine delta theta is equal to change in velocity V over the speed hypotenuse, which is V, as equation 1. We have sine delta theta, which is also equal to the change in displacement S over R, equation 2. Sine delta theta is equal to sine delta theta. It means we can equate the two. So delta V here over V is equal to delta S over R. Let's divide both sides of the equation by time t, because it took the time taken to move from A to B is small time delta theta. So when we divide through by delta theta, okay, we have delta V over delta t. Please, class, what is V over t? What is V over t? Can somebody help?
Acceleration.
So this side is equal to acceleration A over V. Then at the right hand side, we have delta S over delta T. What is S over T? What is S over T?
Velocity.
Velocity divided by the radius R. Let's make A the subject. Help me make A the subject. Hello, help me make A the subject.
V squared is equal V squared over R, sorry.
So V squared over R. This is what is known as the centripetal acceleration. Centripetal acceleration. AC is equal to V squared over R, known as the centripetal acceleration. It is termed centripetal acceleration because it has a direction towards the center of the circle. Centripetal acceleration. So the only situation, and centripetal acceleration is equal to that uniform velocity V, uniform speed V of the body, or that constant speed, a square of it divided by the radius of the circle. Now, from Newton's second law of motion, can somebody help me state Newton's second law of motion? Can somebody help me state Newton's second law of Mamiya?
Please, S is equal to UT plus half AT squared.
No, I want you to state Newton's second law of motion, not equation of motion. Mamiya, not equation of motion. Newton's second law of motion. Anybody? Hey, I treated this with you. So Newton's second law of motion. Oh, Newton's second law of motion says that the rate of change of momentum with respect to time, okay, is directly proportional to the applied force, or the acceleration of a body is directly proportional to the applied force or the external force, and inversely proportional to the mass of the body. Are we okay? Class, are we okay with this?
Yes, sir.
So what it means is
Yes,
that
sir.
for a body to accelerate, there must be an applied force, or every acceleration must be caused by an external force F. So if we have acceleration directed towards the center, centripetal acceleration given by v squared over r, then this acceleration must be caused by a force. So we probe to find out what force causes this acceleration towards the center. And from Newton's second law, F is equal to ma. So F therefore will be equal to the mass of the body times the acceleration or the centripetal acceleration, which is v squared over r. And so therefore, this force which is responsible for this acceleration directed towards the center is equal to mv squared over r. This is what we famously call as the centripetal force. So centripetal force F subscript C is equal to the product of the mass and the square of its speed divided by the radius. So F is equal to mv squared over r. So the body, there is this force because we see the body accelerating towards the center. And if the body is accelerating, okay, then this acceleration must be caused by a force. This force is known as a centripetal force. If you have any question, ask before I continue my discussion. If you have any question, any further clarification, please do not hesitate to raise it. I'm waiting on. So, Nathaniel.
Sir, please, sir. Looking at this formula, can there be any question that they will give you the initial velocity, the final velocity, and they'll say find the centripetal force?
No, no, I'm coming. I just want to upload attendance. Okay, so I'm coming. Just a minute, okay. Okay, so Nathaniel, no, there's no way you'll be asked to calculate for centripetal force when you are given initial velocity and then final, because centripetal force itself is a square of that constant speed v. Okay. Okay, Rachel. Rachel is also asking, can there be a case where we are given the acceleration and force only and told to find the mass in respect to the... Oh, yes. Right after going through this, we'll be solving similar questions. So that we can give you force, the radius of the circle, that constant speed, and then be asked to find the mass. Yeah, that's possible. All right. So the only, you see, in linear motion, when a body is moving with constant speed, acceleration is equal to what? In linear motion, when a body is moving at a constant speed, the acceleration of the body is equal to... No, in linear motion, no. I'm not talking about motion under gravity. Yes, it's zero. Okay, when a body is in linear motion, the acceleration of the body is zero. But the only time a body accelerates, even when its speed or its velocity is constant, is when the body is in circular motion. We see the body to be moving with constant speed, yet the body is seen to be accelerating. So the only situation where a body can move and yet accelerate is when the body moves in circular motion. So this body, which is moving in this direction, okay, the body is moving from A, moving with this speed, but due to change in direction, its velocity changes, and it is here. Due to change in velocity, the body, which is initially moving in this direction, has a change in velocity along this line, and so its final velocity is here. The body is in this direction, but due to changing direction, it has changed in velocity here, and so its velocity now is here. The body moves here. Due to change in direction and change in velocity, it is now here. Its velocity is now, or direction and velocity is now here. The body is going straight. Due to change in direction, it's now here. And so its velocity is now here. When you join all these points, as the body moves along, you see the body describing circular motion as we move on. So circular motion occurs due to the changing direction and change in velocity. Okay, so due to the changing direction of the body whilst in circular motion, there is a change in velocity which causes the acceleration of the body towards the center. So when we continue, that's what will happen. Change in velocity is here, the body direction is now here. Change in velocity, the body is here. So when you continue moving along, it will create a circular path. It will create a circular path as we move on. Okay, now speed or velocity. We use speed and velocity, okay, when we are looking at non-changing direction. So speed v is also equal to omega times r. Because of this, we can also modify the equation of centripetal force to be the mass times omega r squared divided by r, which is mass times omega squared times radius. So this can also be another expression of centripetal force. The same thing can also be applied to centripetal acceleration, AC, which is v squared over r. So we have omega r squared divided by the radius. And this will be equal to omega squared times R. Okay. So if it is this and we substitute centripetal acceleration, which is in terms of the angular velocity here, we'll get the same thing. So this is another relation for centripetal force. All right. Let me check on your messages. Okay. Now, we said that for bodies in circular motion, the centripetal force, which keeps the body in circular motion, is always provided by something. So for a stone tied to a spring, and whirled, the centripetal force Fc is equated to the tension within the string. Therefore, the tension in the string is equal to mv squared over r. Now, when a string is tied to a stone and whirled, please note that the radius of the circle is equal to the length of the string. R is equal to length of string. Let me explain why. This is a string, then at the end, a stone is tied to it. This is where your hand holds. So your hand is here. When you are whirling it to create that circular path, you realize that this length of the string L will be equal to the radius of the circle R. Please, are you okay with this explanation?
Yes.
Okay.
Please.
Then, when a car negotiates a bend or a curve, a car negotiating, Mamiya,
Please, is the tension part, is it V square or V cubed?
a squared. Oh, Mamiya, this is Fc is equal to the tension in a string. So obviously, let me correct this. Obviously, the Fc is the centripetal force, so it cannot be Q. Are you okay?
Yes, please.
In a string or rope. Elsie and Co, are you following?
Yes.
Okay. Okay. So when a car is negotiating a bend or curve, the centripetal force mv squared over r is provided by the frictional force between the road surface and the tire. So we equate mv squared over r to friction. Class, how do we calculate for friction? How do we calculate for friction? Can somebody help? How do we calculate for friction? Elizabeth.
Please, mu r.
Mu times the normal reaction. So where mu is equal to the coefficient of static friction, and R is the normal reaction. R is equal to the normal reaction. When a car is flat, it's on a flat road. When an object is on a flat road, its weight, the weight of the car, which is mg, is balanced by the normal reaction R. So on a flat road, the normal reaction R is equal to mg, the weight of the body. So it means that the centripetal force, which is equal to the friction between the car, the surface of the road and the car, this is mu r, and r is equal to mg. Okay, please, let's make v the subject. Let's help me make v the subject. The masses will cancel out, and we have v squared being equal to mu rg. V therefore is equal to the square root of mu rg. And the value of v must be a value which is less or equal to the square root of mu rg. This v is termed as the maximum allowable or maximum safe speed. What it means is that when a car is negotiating a curve, when a car is negotiating a curve, the maximum safe speed, depends on the square root of the coefficient of friction, and this is a measure of the nature of the road. It also depends on the radius of the curve, or the bend. As for gravity, is constant. It doesn't matter when the road is the curve is large or small, its value does not change. But when a car is negotiating a curve, the maximum allowable speed depends on the nature of the road or the nature of the bend, and also the square of the radius of the. And it is of this reason that whenever it rains, National Road Safety Commission, okay, advise motorists or drivers to reduce speed, because whenever it rains, the frictional force on the surface of the road changes, and so it can affect the speed you can embark on, because we are just saying that the safest speed or the allowable speed depends on frictional force, the coefficient of static friction. And so when it rains, it will reduce friction, and so it must reduce speed. Are we okay? Are we okay? All right. Let's apply this in solving questions. Well, I'm going to give you 1 or 2 questions to see how we can actually apply. Are you there or tired? Class, are you tired?
Yes, sir.
Okay, then let me give you 5 minutes break. It's 4:25. Water break. Go and come. Okay. Class, are you okay?
Yes.
Okay. 5 minutes water break. I'll be waiting for you. So our 5 minutes water break is over. Are we there?
Yes. Yes.
Okay, so we see the maximum allowable speed or safest speed to be V is directly proportional to the square root of mu, meaning that for two different surfaces, nature of surfaces will have two different velocities. When the road is dry enough, we can move at a certain velocity. When the road is so smooth, as in water settling on the surface of the road, it would also reduce the nature of the surface or the road, and so mu would also vary. So for two different nature, let's look at dry road and wet road. So we'll have, if dry, we'll have a velocity for dry road which will be directly proportional to square root of the nature of the road, the nature of the surface which goes with dry. So mu dry. And when the road is wet, V wet, it also go with a certain nature of the surface. So mu wet. And when snowy. So when we take a ratio of this, V dry over V wet, it will be equal to square root of mu dry over square root of mu wet. Okay, so in effect, V dry over V wet would also go with square root of mu dry over mu wet. The constant of proportionality will be 1 because it's the same road surface which is dry and another time wet. So K would be the same. So take note of that. Equally, when the radius vary, we'll have different speed. So V1 would also be directly proportional to square root of R1. Okay, and V2 can also be directly proportional to square root of R2. So V1 on V2 would also be equal to square root of R1 over R2. Take note. All right. So the maximum allowable speed or maximum safest speed must be anything V safe must be a value which is less or equal to square root of mu rg. Anything greater than this value, anything greater than square root of mu rg, the car would skid off the circular track. It will be involved, it will be thrown away from the circular track, meaning for the car to be able to stay within the curve, the allowable speed, the speed must be anything less or equal to this, whatever is here, and shouldn't be greater than, because if it's greater than, it will be involved in an accident. Let's apply this in solving a question. And I'm reading. Please listen attentively. A 1,500 kilogram car. A 1,500 kilogram car moving on a flat horizontal road, moving on a flat horizontal road negotiates a curve. Negotiates a curve. If the radius of the curve is 35 meters, if the radius of the curve is 35 meters, and the coefficient of static friction, between the ties and the dry road, is 0.500. It has no unit, meaning it's dimensionless. And the coefficient of static friction between the tie and the dry road is 0.500. Find the maximum speed of the car. So find the maximum safest, let me add the adjective. Find the maximum safest speed of the car. A 1,500 kilogram car moving on a flat horizontal road negotiates a curve. If the radius of the curve is 35 meters and the coefficient of static friction between the tires and the dry road is 0.500, find the maximum safest speed of the car. This is the problem of the day. 3 minutes. Let's solve this within 3 minutes. We must be through by now. So maximum allowable speed or maximum safest speed is equal to, it should be a value which is equal or less than square root of mu rg. So if mu is equal to 0.5 and radius is 35, gravity is 10, acceleration due to gravity is 10. Then we have square root of 5 on 10 by 35 by 10. So what is 35 by 5? So class, what is the square root of 175? Mameya, Nathaniel.
13.23.
So what it means is that for the car to be able to stay within the bend without skidding off the circular road or track, its speed must be less or equal to 13.23 meters per second. Please, how many of us got this correct? Show by hands. If you got it right, all right. 3, 4. Okay, I have 4 hands. Oh, more hands. Oh, okay. Ayo, you came late. Samson, you came in late. All right. Another question. Another question. An object of mass 50 kilogram. An object of mass 50 kilogram moves round a circle of radius 6.0 meters. An object of mass 50 kilogram moves round a circle of radius 6.0 meter with a constant speed of 30 meters per second. So Nathaniel, listen, with a constant speed of 30 meters per second. Calculate I, the angular velocity. Calculate I, the angular velocity. And then II, the centripetal force. The centripetal force. Make me proud within 4 minutes. Just 4 minutes. Calculate I. Hello.
Please, the radius again.
Let me take the question again. An object of mass 50 kilogram moves round a circle of radius 6.0 meter. So 6 R is equal to 6.0 meter. The mass is 50.00 kilogram. Okay, with a constant speed of
The angular velocity.
5. I'm coming. 10.0 meter per second. We are to calculate I, the angular velocity, II, the centripetal force. Let's run through this with some speed because we are smarter than this sort of questions. Mami ya.
Please, can we say the answer?
Okay, no, we will solve it so you mark whatever you are doing, okay?
Okay.
We have 2 minutes to go. 2 minutes. Okay. I think our time is up. So, solution. Once we have the constant speed, angular velocity omega would be equal to V divided by the radius. V is 10 meters per second. The radius is 6. So this must be 1.67 radian per second. Then the centripetal force F is m omega squared r. And I'm using this because we have determined omega. So the mass is 50 times omega is 1.67 squared and the radius is 6. This must give us 83.3 Newton. Let me see by hands whoever scored everything. If you scored everything, let me see you. I'm watching. Oh, I have 3 hands so far. Oh, Rachel, Calvin, Nathaniel. Oh, it's rather unfortunate. Eva, what happened? Fifi Pepra, what happened? Okay.
Mr. Edia, please, I have a question.
All right, do so.
Please, for the centripetal force, I use the F is equal to mv squared over r.
Okay, let's see. The mass is 50 times 10 squared over 6. So we have 5,000. Okay, 5,000 divided by 6. Let's divide 5,000 by 6. Let's see.
Please, I had 833.3.
Let's calculate this again. 1.67 squared times 50 times 6. 1.67 squared times 50 times 6. Let's see what that will give us. Oh, it should be more than. It should be more than.
I got
836.
Yeah, so it's a mistake. It's not 83. I think it's a mistake from the book. I was quoting what the book had written. Is that 833? Okay, so thanks for
836.67.
Okay.
Hello.
Please, when you use the F is equal to
MV squared over.
when you use that one, you are getting a different answer. And when you use F is equal to mv squared over r2, you are getting a different.
Let me punch it myself. I'm coming. So I just want to confirm 1.67 squared (50 times 6). This is, where's my pen? My pen is lost. This is equal to 836.7 approximately, and 5,000 divided by 6. This is also giving us 833.33. What is the reason? Oh, okay, the reason is clear. I've seen what is responsible. You see, look at this value, It's a 1.67 is a rounded value. In using it, if I use, don't forget 10 over 3 is 5 over 3. So if I use F is equal to 50 times 5 over 3 all squared times the radius, which is 6. It must give me the same figure as when I use mv squared over r. So 50 times 25 over 9 times 6. Okay, or 50 times 25 times 2 all over 3. Let's confirm. I want you to calculate that for me. So 50 times 50 is 2,500. So divide 2,500 by 3.
If you get 833.
Go. So yeah, the same answer as this. So the problem was rounding off this value. Okay, rounding off this value. Ideally, its value is 1 point that recurring 6, but we rounded it off to have 1.67, and that's the reason for the difference. Okay, and this is the reason why in exams, you see, where if you calculate a value and there is a need of you to use that value calculated in determining another, do not run this to the nearest 2 decimal place. At least 1.6667 would have brought this closer to this. Please, are you okay with what I'm saying? Are you?
Yes,
and that does not
Yes.
also mean
Yes,
that
sir.
go and write all that lengthy value. At least 4dp, 3dp, 4dp will do, especially when there is a need of you to use that value in determining another. Do not run your answer to the nearest whole number. Last question, and then we smile to the bank. A stone of mass 50 gram is tied to a string. A stone of mass 50 gram is tied to a string and whirled round in a circle of radius and whirled round in a circle of radius 0.65 meter. In a circle of radius 0.65 meter at a speed of 5 meter per second. At a speed of 5 meter per second. Calculate the tension in the spring attached to the stone. Calculate the tension in the spring attached to the stone. Nathaniel.
So please, can you repeat the question?
Oh, yes. A stone of mass 50 gram is tied to a string and whirled round. Is tied to a string and whirled round in a circle of radius 0.65 meter. In a circle of radius 0.65 meter at a speed of 5 meter per second. At a speed of 5 meter per second. Calculate the tension in the spring attached to the stone. Calculate the tension in the spring attached to the stone. So, Rachel, significant figures, you see, they count, but they count when it is an instruction in the question. Now leave your answers to the so and so significant figures or decimal places. If there is no instruction of that sort, you must always express your answer to about 3 dp, especially when one result would lead in determining another. You shouldn't run it to the nearest dp or sm. It can affect the accuracy of your results. You do that when you are instructed to do that. Rachel, is that okay? I think you must be through by now. This is a straightforward question. Are we through?
Yes, sir.
Okay, so let's quickly solve it and wash our hands of today's section. So we are to determine the tension in a string. Tension is equal to mv squared over r. So when a stone is tied to a string, the tension is equal to, or the centripetal force is equal to the tension in a string, and the tension is also equal to that. So we have the mass as given as 50 gram. 50 gram is equal to 0.05 kilogram. 50 divided by 1,000. V squared, the V is 5. So 5 squared divided by the radius, which is 0.65. And so this must give us 1.92. 1.92 Newton. Please, is that correct when you calculate?
Yes, please.
Yes, please.
Okay, so let me see by hands those of you who had this correct. This one, I think everybody must have it. 9 hands, 10. Okay, yes. Okay, thank you so much. Yes. Okay, so this is our time is almost up. This is where I draw the curtains on today's meeting. Okay, your physics engagement ends today, and within the week, I'll review my schedule tomorrow to see if I can make up for the lost period within this week. Okay, so it would certainly be updated on the platform, but expect your weekend challenge as well. Until then, may the good Lord be with you. Take care of yourselves and bye-bye. Please, when you go to the page, you subscribe and share if you have not done so. Please, especially the subscription. If you haven't done so, kindly do that for me. Okay. Your video too will be uploaded. Bye-bye. Mommy, your hand is still up. Eva, your hand is still up. What's your secret? Okay. Bye-bye then.
Bye.
Okay.
Au revoir.
Au revoir.